Okay, welcome back. Example 2. Calculate rates of change. So for the linear relationship. Now, you gotta be able to read, kids, and I know you don't, so start. Linear relationship, they're telling you it's linear. I know it's linear. You know how I know it's linear? Because it's in this form. Y equals mx plus b. What's the m value here? Let's jump ahead a little bit. Let's see if you know what you're doing. What's the m value here? 2. Excellent. And if you wanted to, you could make it 2 over 1. So you see the rise and the run, right? If you just make it 2, sometimes kids get upset and say, well, then there's no run. Yeah, there is. It's a 1. Get it? 1, run. It rhymes. Yeah, okay. And what's the b value here? 5. Good stuff. So that's my m. That's my b. Okay. Complete the table below and determine the rate of change in the y values. So we have to complete the table below. And this is a linear relation that follows the rule y equals 2x plus 5. Now you get to choose the values of x that we put in. In this particular question, they gave you 0, 1, 2, 3, and 4. So what we're going to do is we're going to put in 0 for x. We're going to put in 1 for x. We're going to put in 2 for x. We're going to put in 3 for x. We're going to put in 4 for x. And I did all of those at once to show you exactly what we're doing. We're taking these values of x that they gave us, and we are putting them into the equation for the x. And what we're interested in is what is the overall y value that pops out of this function. So 2 times 0 is 0, plus 5 is 5. 2 times 1 is 2, plus 5 is 7. 2 times 2 is 4, plus 5 is 9. 6 plus 5 is 11. 4, 8, 9, 10, 11, 13. So that's how that works. Now, what you really should have here as well, I would, if you've got room, throw down another line, and let's put in x comma y, because that's really what we're creating here, isn't it? And what we've got is 0 comma 5, 1 comma 7, 2 comma 9, 3 comma 11, and 4 comma 13. So you actually have 1, 2, 3, 4, 5 points that go on this line. 5 points. Now, rate of change. There's all sorts of different ways of figuring out this rate of change. But probably the easiest at the moment is to take a look at our formula. M, which stands for slope, is change in y over change in x, which means rise over run, which means y2 minus y1 over x2 minus x1. And ladies and gentlemen, you better memorize that. You better know that, you better know all of it, and you better be able to use it. Now, which one am I going to use is this one. So I have to pick one of my points to be x1, y1. It needs to be point 1. And my other one needs to be point 2. It doesn't matter which one you choose. Any of these will be fine because the slope between any 2 points on a line is constant. So let's pick this as point 2. So this one's going to be point 2. Let's have this one be point 1. I randomly chose those. So this will be x1, this will be y1, indicating that it's point 1, right? The x value for point 1, the y value for point 1. Notice that these are what's called subscripts. They're little tiny numbers just below the variable. So this is point 2, so this is going to be x2, y2. And look how I wrote it above. Isn't that such a good idea? If you guys do this, you'll never get it wrong. So let's put in for y2. y2 is supposed to be 11. So over here I'm going to get 11. y1 is supposed to be 7, so subtract 7. Over top of x2 is supposed to be 3. And x1 is going to be 1. So do you see what I did there? I put in the value. You can't see what I did there, the kids in class. I got something in the way. There we go. So do you see what I did there? I took this x1, y1, I took this x2, y2, and I plugged them in where they went. I took these and put them in here, and I took these and I put them in here to get this. So what does that give us? That gives us, what's 11 minus 7? 4? What's 3 minus 1? 2? So the slope is going to be 2 over 1. And again, I suggest that you make it 2 over 1, not just 2, because that shows you what your run's going to be. Now again, in the unit before this, when we were working with integers, I would have always told you don't leave your answer as 2 over 1, always change it to 2, but we're doing things different now. This is a different unit. We're using the numbers differently. So therefore, the rate of change of the y values. So this is just asking the y values. The rate of change of the y values is 2 for every change in the x value. So in other words, every time I change the x value by 1, the y value is going up by 2. And you're going to remember that a little bit from when you did first differences. Remember, you sort of looked at the difference between here, between 0 and 1 is plus 1, between 1 and 2 is plus 1, between 2 and 3 is plus 1, between 3 and 4 is plus 1. So all of the differences in the x values are going up by plus 1, right? And what's happening with the y values? Well, all of the y values are going up by plus 2. So 5 plus 7 is plus 2, 7 plus 9 is plus 2, 9 plus 2 is 11, and 11 plus 2 is 13. So when we see this type of pattern, and this is going to come up when we talk about finite differences, when we see this type of pattern where each x value goes up successively by 1, and the y values go up by a constant value, goes up by 2, goes up by 2, goes up by 2, goes up by 2, that's linear. And the equation's going to look like that, and you're going to get a slope. So that's the whole idea of grade 9 put together pretty quick. Let's take a look at the next one. I'll pause the video here and we'll do the next example.